Okay, hi everyone. In this video, we're going to go ahead and talk about balancing chemical equations, some of the essential skills and steps you should be taking. Then we'll go through a few examples, and then we'll be practicing this the next few days. So let's go ahead and get started. Okay, so there's a few different steps for balancing chemical equations. The first thing we want to go ahead and do is to complete an atom inventory, because that's Okay, so there's a few different steps that we want to take when we're balancing chemical equations. The first thing that you need to do is to write your atom inventory that we talked about earlier. And this is really helpful because it lets us see what is balanced and what is unbalanced. So it gives us a starting spot. Once we have the atom inventory, we're then going to start to add coefficients in front of the compounds that are unbalanced. Now remember, the coefficients are the big numbers and they apply to everything that comes in that compound. So we need to make sure that we're thinking about how it impacts all the things in that compound. The other thing I want to remind you is that we never, ever, ever change the number of the subscripts, either adding or changing, because if we do that, then it changes the entire compound. So instead of having something like water, H2O, if we change it to H2O2, now we have hydrogen peroxide, which is completely different. So we never change the subscripts, we only change the coefficients. Next, as you're adding those coefficients, don't forget to update your atom inventory. So as I stated before, that coefficient applies to everything that comes in the compound. So if I put a 2 in front of H2O, it applies to both the hydrogen and the oxygen. So I need to make sure I'm updating my atom inventory with all the things that are being affected. And then finally, after balancing my equation, I want to check to see if I can reduce the coefficients in my equation. If I can, I need to go ahead and get them to the most simplified form possible. Okay, so some tips to go along with those steps. So the first thing I highly recommend for balancing chemical equations that you use a pencil. I guarantee at some point in time you will need to erase something, change it, start over. Using a pencil makes things much neater and your life easier in the end. So even if you don't like pencils, use it for this one thing. Next, when you're writing out your chemical equations, make sure to leave an extra spot in front of each compound. That way you have space to add a coefficient if you need to do it. If you have any elements that are by themselves, so just a sodium or just an oxygen or just a hydrogen, even if it's an O2 or H2, balance whatever that is last. The reason why is the other part's going to be trickier, so by saving that single element for last, it makes it really easy to wrap things up. Next, you want to look for polyatomic ions. So if you have something like phosphate, PO4 in your compound, you can treat it as one unit or one element and kind of balance it together. So that saves you some time instead of separating it out into the phosphorus and the oxygen. Next, for combustion reactions, we'll talk more about these later this week, but combustion reactions only contain carbon, oxygen, and hydrogen. So for combustion reactions, you want to balance the carbon first, the hydrogen second, and the oxygen last. Okay, oxygen last. Sometimes we're going to need to multiply the entire equation by 2 for combustion reactions in order to make everything work out. So we'll do a lot of practice with those as well. And then finally, sometimes you're going to get stuck. Sometimes it even happens to me still, and I've been balancing chemical equations for a long time. So if you're to the point where you've looked at it, you're stuck, you don't know what to do, erase all the coefficients and start over. Sometimes we kind of go down one track and our mind gets set into that pattern where really we kind of made a simple mistake earlier on. So sometimes just erase, take a deep breath, and start over. Okay, so let's go ahead and work through some examples. Okay, so let's go ahead and work through some examples. I'm going to be breaking one of my tips I just gave you to use pencil, just because I want to make sure that you can actually see these really well. And I hopefully you remember how to do all these really easily because I've done them a couple times. So for the first one, let's go ahead. We're going to start with our atom inventory. So we draw that vertical line down below, and then we're going to list all of the elements we have. So in this case, we have iron and we have oxygen, and we'll list them in the same order on both sides. So then I'm going to do my initial inventory. So for iron on my left-hand side, I have 1 of those. For oxygen, I have 2. And then on my product side, I have 2 iron and 3 oxygen. Okay. So if I look here, my iron's unbalanced and my oxygen is unbalanced. So I'm going to go ahead and start on the product side. Just because if I look here, I see that oxygen has 2 on the left-hand side, and I know anything I multiply by 2 is going to be an even number. So I want to get an even number of oxygen on the product side as well. So always start with small numbers. Don't jump to 10 if 2 will work. So in this case, we're going to put a 2 right there. And when I do that, I need to update all of the atoms that are affected. So in this case, it gives me 4 iron and 6 oxygen. So I go ahead and update those. Now, if I go ahead and look, I'm not really any closer to balancing. It doesn't seem like, because I'm still not balanced, but we can go ahead and make some good progress from here. So for my iron, if I have 4 on the product side, I need 4 on the reaction side. So I go ahead and put a 4 there. And notice this time only the iron is impacted by that coefficient. Now for the oxygen, I need 6. So what times 2 gives me 6? Well, 3. So I'm going to go ahead and put a 3 in front. And again, update my atom inventory. So that is the balanced chemical equation. And if I check, I cannot reduce it because 4, 3, and 2 do not have a common number that I can divide them by to get smaller ratio. So that's that answer. So let's go to the next one, which is the formation of water. Okay. So again, I'm going to start by drawing my atom inventory. So I have hydrogen and oxygen. On my reactant side, I have 2 hydrogen and 2 oxygen. So I'm going to start writing those down. And then on my product side, I have 2 hydrogen and 1 oxygen. Okay, so here my hydrogen is balanced, but my oxygen is not. Okay, and I can't make these numbers any smaller. I can only make them larger. So instead of having 2 oxygen on the left, I'm going to get this to 2 on the right as well. So in order to get to 2, put a 2 there, but notice this coefficient applies to both the hydrogen and the oxygen. So now my oxygen is balanced, but my hydrogen is not balanced. That's okay. That often happens when you're balancing chemical equations, that sometimes something is balanced and then it's not balanced, but then you can go back and fix it, okay? So now, the only thing I have to fix is my hydrogen, because hydrogen is by itself. That's really easy. So what times 2 gives me 4? Well, 2. Okay, so that is going to be my balanced chemical equation. Now notice I have a blank spot in front of my oxygen. I could put the number 1 there if that makes me feel more comfortable, but you don't need to fill in that spot. When we list O2, it automatically means we have 1 of them unless we have a coefficient. So if you want to put a 1 in there, you can. I usually don't, just because it's extra writing I don't have to do. So if I look at this, I cannot reduce it because 2, 1, and 2 cannot get reduced down. Now if I had 4, 2, and 4, if I went to kind of too big a coefficients too fast, then I could reduce that down to the 2, 1, 2. Okay, so I hope that helps. If you have any questions, please let me know. Bye.